In this lecture, inshallah, we will start with chapter 3. In chapter 3, we have polynomial and rational function, also polynomial and rational inequality. Also, we have some variation, equation of variation. Okay, this is the main subject in this chapter. Firstly, we talk about the quadratic function and some application on the quadratic function. What's the meaning quadratic function? Quadratic function, this is function f of x, okay, with degree 2. So we have x square and x and term constant, okay, but must be a not equal 0. This is the coefficient of x square. This is polynomial, but if we have the polynomial with degree 2, so this is called the quadratic function. Quadratic function, this is the parabola. When we graph the quadratic function, we have like this or like this, okay? So we have two cases, and this is the vertex. If the parabola concave to up, we have vertex, minimum vertex, okay? This is minimum vertex. If we have parabola or quadratic function concave to down, so this is called maximum vertex, okay? Now, in quadratic function, this one, we can put it as vertex form. So we need to convert this form and this form. If ask you find the vertex form, so we need to convert the quadratic function to the vertex form. This is the vertex form. In this form, we can obtain the vertex point. The vertex point, this is the head of parabola, okay? And this is A. From this A, we can conclude if A greater than 0, so we have concave up and the vertex minimum. If A less than 0, negative, so we have parabola to concave to down, and the vertex, this is the maximum. The vertex here or from here, this is we can obtain from the vertex form of a quadratic function by h and k. H and k. This is h, the value of x coordinate. In equation or in vertex form, we have minus h. We take h. So if we have minus 2, the h equal 2. If we have plus 2, the h equal negative 2, like this, okay? And the k, this is the y coordinate. So if we have f of x at this form, and we need to find the vertex for the quadratic, and the f of x equal, for example, 3x minus 4 square plus 2. So the vertex equal what? 4 and 2. If we have 3x square minus, for example, 5, the h equals 0 and the k equal negative 5. Okay, this is the vertex of the quadratic form. Any question? Any question? Look at this. This is the vertex form of for a quadratic function. H and K, this is the vertex. Okay. If A greater than 0, we have parabola open to up, and we have minimum value of the function, because concave to the up, the vertex is minimum, vertex H and K. If we have A less than 0, negative, so we have concave down. And this vertex, this is maximum or minimum? This is the maximum. H and K, this is the maximum. Also, we have axis symmetry, X equal H. So this is symmetry. This is symmetry, X equal H. Always X equal H. This is the symmetry. Symmetry means the line, the graph, on the left of the line, this is mirror for the on the left of the line. So if we have symmetry, this symmetry, and we have this graph, for example, so must we have in the left hand side the same curve as mirror. Okay, so this is the symmetry. This is X equal H. Okay. Now, also maybe have the x-intercept. We can obtain this x-intercept by put it the f of x equal what? Equal 0. If we need to find y-intercept, so we need to find f is 0. So this is to find the y-intercept. Y-intercept means what? 0. And we need to find the f is 0. Okay. But if we need to find x-intercept, so the value of f of x equal 0, and we need to find the value of x that f Lx equals 0. Example, look at this function. This is not in a vertex form. Why? Vertex form in this form, a x minus h and have square plus k. Okay, so in the vertex form we cannot find the x square with x square with x, sorry, x square with x. This is not in the vertex form. In vertex form we have x and we have brackets all to the power square, or we have x square only without x. Okay, this is the vertex form. This is vertex form. But if we have x square and x, this is not vertex form. Now, if we need to convert this quadratic function to vertex form, we must find the complete square. Find the complete square. First step, take the coefficient of x square as common factor. This minus 2, take it as common factor from x square and plus 4. So we have x square minus 2x. Now we need to add and subtract the value of this one, minus 2, always over 2, all square, like this. Minus 2 over 2, all square. Any complete square, we need it to, for example, we have x square plus, for example, bx plus c. Take this, if we need to find the complete square, take b and divide by 2 and find the square. So we must plus, now we can add and subtract this value. We can add b over 2 square and subtract b over 2 square. Take this one with this one, 2 terms, we have 3 terms. This is the complete square. So we can put it as x plus b over 2 all square plus c minus b over 2 all square, like this. Now, again, return to these steps. So we have minus 2 over 2 equal 1. So add 1 and subtract 1. Okay, add 1 and subtract 1. The 3 terms, x squared minus 2x plus 1. This is the complete square. But we need to find the negative 2 multiplied by negative 1, and this is put it outside the brackets. Okay, no need minus 1 inside the brackets. So we need minus 1 outside the brackets, but minus 1 multiplied by negative 2. So we have 2 here, sorry. So we have negative 2, negative 1, we have 2. And these 3 terms, we can find the complete square by x minus 1. X, this is the radical of x squared. And 1 radical of this 1. Negative from the negative in the second term. If we have in the second term positive, positive, negative, negative. So we now convert the quadratic formula to the vertex form. And we can conclude if A negative, so this is parabola open to what? Up or down? Open to down, because we have negative, the coefficient of the brackets. And the vertex, we can take this is 1 and 2. This is the vertex. Okay. This is the vertex maximum or minimum? This is maximum because parabola concave to down. So the vertex 1 and 2, this is maximum point or minimum maximum? Maximum value. Okay. And what the symmetry? Symmetry, this equal always x equal h. What's the value of h? 1. So the symmetry equal 1. Any question? Any question? Now, we need to find the x-intercept and y-intercept for the same quadratic formula like this. We have f of x equal negative 2x squared plus 4. And we need to find x-intercept. X-intercept means f of x equals 0. So we need to solve this equation. We have this is x. We can take x as common factor, so we have minus 2x plus what? Plus 4. So we can conclude we have 2x, x equals 0, and minus 2x plus 4 equal 0. So this is the first point, and the second point, minus 2x equal negative 4. By divide by negative 2, so x equal 2. So we have 2 value of x. If substitute x equals 0, so we have point 0 and f is 0, 0. If substitute 2 in this equation or in this function, we have 2 and minus 2 multiplied by 2 square, we have minus 8. minus 8 plus 2 multiply 4, this is also 0. If we have other than 0, this is not y-intercept. So we can just for verify, if substitute in this example, if substitute 0, we have 0. If substitute 2, we have 0 also. This is x-intercept. So this is point, this point the x-intercept. If we need to find the y-intercept, we have f is 0. Okay, because y-intercept is x 0, so we need to find f is 0. The value of y at x equals 0 equal what? 0, substitute 0, so we have 0. Okay, look at this point. This is the vertex, this is the maximum, concave down, and y line symmetry or symmetry at x equal 1. Look at the x-intercept, we have 0, 0 and 0 to 0. This is the x-intercept. Also, what's the value of y-intercept? Also 0, 0, 0, 0. This is point for x and y-intercept. We have only one point that in intersection or can be called as x-intercept and y-intercept. This is 0, 0 only. Okay. Any question? The vertex formula, if we need to find the vertex, this is the vertex. We can, if we have f of x equal ax square plus bx plus c, so we have a, this is the coefficient of x square, b the coefficient of x. We can find the vertex by this formula, minus b over 2a. This is the x-intercept, and substitute this x-intercept, substitute the x value. This is not x-intercept, this is vertex. Substitute the value of the x coordinate in f of x to obtain what? To obtain the y. For example, here we have 2, so a equal 2. We have the coefficient of x minus 8, so we have b equal minus 8. And the c equal what? C equal 1. So the x coordinate minus b over 2a, this is minus negative b, this is negative 8 over 2 multiply a equal 2. So we have 2 multiply 2. In numerators, we have minus 8. Look at this. We have negative 8. In denominators, we have 8 over 4. This is equal what? This is equal 2. This is the x coordinate. So x coordinate done. Now we need to find the y coordinate. Substitute this in the value of the function. So we have f2 equal what? 2 multiplied by x square, we have 2 square. This is the 8. Okay. And minus 8 multiply x. So we have minus 8 multiply 2. This is negative 16 plus 1. So we have 8 minus 16, negative 8. Negative 8 plus 1, we have negative 7. So by this formula, this is very important to find the vertex of a quadratic function. Any question? Any question? Now, introduction to polynomial function. We can put it the polynomial function In general, we have polynomial function. From polynomial function, we have linear, quadratic, with degree 3, with degree 4, and so on. Okay? So, what's the formula or form of the polynomial function? This is the form of polynomial function. We have an x to the power n, and an minus 1 x to the power n minus 1, and so on. Okay? For example, about this polynomial f of x in quadratic formula 5x squared plus 3x minus 2, this is polynomial. Also, f of x equal 5x minus 1, this is polynomial. Or f of x equal x to the power 4 minus x squared, this is polynomial. So polynomials means that we have x in numerators, the power of the x positive. Okay, we don't have power negative for the x, but the coefficient we can put it negative, positive, rational, any number. We don't have in polynomial x inside the, for example, radical, or x in denominators في المقام. So all x's in numerators and power of x positive. But the coefficient we can put it negative, positive, 0, any value of the coefficient. So the degree of polynomial, this is the large power of the x. For example, here with degree 2, because the exponent, large exponent or highest exponent equal 2. So what's the value of the maximum power? This is 1. So this is with degree 1. Look at this. We have power 4 and 2. So the maximum 4 or highest 4. So this is polynomial with degree 4. Okay, so we can find the degree easy by the maximum power of the unknown x or the variable x. So look at this example. This is polynomial, yes, polynomial. Why? Because x to the power 5, we have x to the power 3, x squared, x, all powers positive. So what's the degree of this polynomial? This is equal 5 because we have the highest exponent equal 5. Okay, so this is polynomial function with degree 5. Look at another function. We have x in radical, or x in denominators, or x in logarithm, okay, or x to the power 3 over 2, for example, or x to the power minus 2. This is polynomial? No, this is not polynomial. Okay, not polynomial. Why not polynomial? Because we have x in denominators. When raise this x to up, we have x to the power negative 1. This is not positive. Okay, this is not positive integer. We must be the exponent positive integer. So we have x to the power 1, 2, 3, 4, 5 to infinity. But we don't have, this is the value of x, this is x to the power half. The value of exponent, this is minus 1. So this is not polynomial. Okay? The zeros of polynomial function. Zeros of polynomial function defined by, for example, y or f of x. This is find the value of x that become f of x equals 0. This is the zeros of the function f of x. Okay, this is the real solution. Also, we can call this is the solution of f of x or roots of f of x. Look at this function in example 3. We need to find the zeros of function. Means find the value of x that substitute in f of x equal 0. So we have x squared equals 0, or this one equals 0 to x minus 3 equals 0, or x plus 2 equal 0. I take the radical from x squared, so we have x equal 0. Also, if we have this is square, if we have brackets to the power equal 0, so inside the brackets it must be equal 0. Okay, so we can take the 2x minus 3 alone, or 2x minus 3 all to the power 2. So after take the radical, we have 2x minus 3 equals 0. So x equal 3 over 2. Now here we have x equal negative 2 also, like this. So how many zeros of f of x? We have the 3 zeros, 3 value of x's that become f of x equal 0. This is called roots or zeros of polynomial. Now, we have the point 0, 0. After find the value of x. Okay, substitute these values of x, we have always 0, 0, 0, because this is the 0 of the function of x. Okay, like this. Look after a graph, this point we have minus 2, 0, and we have 0, 0, and we have 3 over 2, 0. 3 zeros of point. This is also the x-intercept. This is also the value of x-intercept. How can verify if we have zeros of function without a draw? We can verify by intermediate value theorem. This called, if we have f of x, look at this. If we have f of x and we have a and b, this is a and this is b, a less than b, and FLA and FLB opposite sign means one negative and one positive. If FLA negative, FLB positive. If FLA positive, FLB positive. So we have different sign, opposite sign. One positive and another negative. So if we have, for example, if we have at A, FLA negative, and at B, we have FLB positive. So after a draw, we have intersection point from a graph and x-axis. So we have x-intercept. So we have zeros of f of x. Okay, for any polynomial. Also, if we have for example, a and b, and point FLA positive, FLB negative, after a draw, we must have x-intercept, and this is the zeros of f of x. So this theorem, if you have polynomial and FLA less than B, so A or B different, FLA and FLB opposite sign, if this is positive, this is negative, if this is negative, this is positive, multiply FLA by FLB must be always negative. So we have at least 1 0 for what? For f of x on this interval A and B. Look at the example 5. This is the value of, this is the polynomial. We need to verify this has at least 1 0. We have 1 0 on the interval what? Between 2 and 3. So we have a 0 between 2 and 3. Now substitute 2 in f of x and substitute 3 in f of x. If we have different sign, so absolutely we have a zeros between 2 and 3 for f of x. After substitute 2, we have 2 to the power 3 minus 2 square plus 3 multiply 2 minus 8. This is 8. This is negative 8. This is 6. This is negative 8. 8 with negative 8. 6 minus 8, we have negative 2. After substitute 3, we have 27, 18, and 9, negative, and negative 8. So we have 27 minus 18, we have minus 9. With 9, we have, 27 minus 18, we have positive 9. 9 plus 9, 18. 18 minus 8 equal positive 10. So we have different sign or opposite sign. So this is surely f has a 0 on the interval from 2 and 3. Okay, we have a 0 or 2 0 or 3 0, at least 1 0 between 2 and 3 for this function. Already have it. Okay, this is from example, Abdullah. From example, ask you to show that f of x has a 0 between 2 and 3. اوكي واضح يا عبد الله؟ يعني هنا راح يقول السؤال نكتبه بطريقة ثانية. show that f of x equal, for example, x to the power 3 minus 2x squared plus 3x minus 8 has at least 1 0 on the interval 2 and 3. Okay, this is different written. Okay, so how can verify? We must put it f of x polynomial. You must put it the conditions. Okay, if we need to implement the theory, we have some condition. For example, this theorem for polynomial. Okay, so f of x is polynomial. It's 2 less than 3. f2 and f3 opposite sign. So we have at least 1 0 for f of x between 2 and 3. Now, division of polynomials and remainder and factors. Division of polynomials, we have two polynomials, for example, in numerators and denominators, and we need to find the quotient, the remainder. Okay, so look at this. If we have A over B like this, A over B, we put it A here and B here. We have remainder, quotient, and after many steps we have remainder. Okay, A over B, this equal what? This is equal the quotient plus the remainder over B. Okay, A, this called the dividend. And the B, this called divisor. يعني بالعربي dividend المقسوم A ال B اللي هي divisor القاسم Q quotient اللي هو ناتج القسمة R الريميندر. واضح؟ فهذول هذا quotient sorry and the R remainder. Okay, this is the parts of division of polynomials. Look at this. We need this one. I put it this one. We need to find 6x to the power 4, to the power 4 plus x to the power 3 plus or minus 7x plus 1 over 2x squared minus x. Okay, now we have A over B. We put it A 6x to the power 4 plus x to the power 3 minus 7x plus 1 over 2x squared minus x. Now, the first step, divide the first term over the first term. This is equal what? This is equal 6 over 2, 3. X to the power 4 over x squared, we have x squared. Now, multiply this one by the 2x squared minus x. So we have 6x to the power 4 minus 3x to the power 3. Now we need to subtract, or this is positive, convert to negative. This is negative, convert to positive, and find the addition. always remove, we can remove, if don't remove the first term with the first term, this is, we have some mistake. Always must be removed. Now, we have x to the power 3 over 3x to the power 3. So we have 4x to the power 3. Now again, divide this one, the first, firstly, down 7x plus 1 also, because we don't have any term in x or constant. Now, divide the first term by the first term. 4 over 2, we have 2. X to the power 3 over x squared, we have x. Now also multiply. 2 multiply 2x multiply 2x to the power 3, 4x to the power 3. 2x multiply negative x, we have minus 2x squared. Now, this is positive, convert to negative. This is negative, convert to positive. Add, remove the first terms, and we don't have x squared. This is minus 7x. We cannot add minus 7x with positive 2x squared. We cannot. So, put it 2x squared and negative 7 plus 1 down from, because we don't have the constant and term in the x. Again, divide the first term with the first term, 2 over 2, 1, and x squared over x squared, 1. So we have 1. Multiply 1 by 2x squared, multiply 1 by negative x, so we have positive. This is convert to negative, this is positive. Remove this one with this one. Minus negative 7x plus x, we have negative 6x plus 1. This is, we can stop. Yes, we can stop. Why now stop? Because we have in remainder x, but in divisor x squared. If we have here the degree less than the divisor, so you must stop. Okay, now this is the quotient, this is the q of x, this is the r of x, and this is the divisor or dividend. Some box put it as this is a and b also. So this one equal what? This is the q, 3x squared plus 2x plus 1, okay, plus q, this is the q plus r of divisor, r equal minus 6x plus 1 over the divisor 2x squared minus x. So this is the result. Okay, any question? Any question? Okay, return. من فين الون؟ أي واحد فيهم يا عبد الله؟ اللي في الكيو ولا اللي في الريميندر؟ السؤال مبهم يعني، كثير 1 في الكيو. لما قسمنا هذه قسمناها، هينا أنا حاطها بالأزرق اللي تحتها خطوط أزرق، يعني قسمنا هذا الخطين اللي في الأول للترم الأول، الخطين في الثاني قسمة للترم الثاني، الخطين اللي بالأزرق في الخطوة الثالثة هذا للترم الثالث. أوكي يا عبد الله، فقسمنا 2x تربيع مع 2x تربيع أعطانا 1. Synthetic division can be used also to divide polynomial. Okay, but divide on the x minus c, just x minus c, x without any coefficient, coefficient equal 1. We cannot divide or use synthetic division if we have this one or we have x square, we cannot use it. Okay, just use it if we have divisor x minus c only. Okay, so look at this example. Find this divisor. This is the dividend and this is the divisor. If we need to use the synthetic division, firstly put it like this. Okay, wait. Firstly, put it like this. We have minus 2. Okay. This is from the opposite of the c. So if we have x minus c, put it here c. Okay. Negative, put it positive. Positive, put it negative. So we have now plus 2, put it negative 2 here. Okay. Now we have x to the power 3 and x squared. We don't have x, but put it the value of x and the number. What's the coefficient of x to the power 3? This is the dividend. The coefficient of x to the power 3, 4. The coefficient of x squared, negative 2. The coefficient of x equal 0. And the constant equal 5. Like this. And put it the line. So we have a 3 row, but 2 column. Okay. The first column for, the first column for the coefficient of the constant of divisor is c, and the second column, this is the coefficient of each term in x. Okay, x to the power n. Now, firstly, down the 4. Now multiply by 4 with negative 2. This is equal what? Negative 8. So put it negative 8. Add this one, we have negative 10 by addition this one. Now also multiply this one with negative 2. We have 20. Add 0 with 20. We have 20. Multiply 20 with negative 2. We have negative 40. Add 5 with negative 40. So we have the negative 35. This is the remainder r, and this is the coefficient q. This is the q. The q equal what? The q equal 4x squared minus 10x plus 20. Why put it x squared? Because we have x to the power 3. So less than by 1. Okay, in the quotient or بناتج القسمة دائما أقل ب1 من الديفيدند من المقسوم. Okay, so this is the quotient and this is the remainder. So we can put it the division 4x to the power 3 minus 2x squared plus 5 over x plus 2. This is equal the quotient 4x squared minus 10x plus 20 plus the remainder minus 35 over the x plus 2. This is the divisor. Any question? Any question? Now, we have another theory, remainder theory. If we have a polynomial f of x, and this is divided by x minus c, then we can compute or find the remainder directly by substitute f l c. In the previous example, if f of x equal 4x to the power 3 minus 2x squared plus 5, and divide this one, divide 4x to the power 3 minus 2x squared plus 5 over x plus 2, we can find the remainder, only the remainder. Okay, we can find directly by find f in negative 2. This is f is c, f is c, is c negative 2, because the c here plus 2, the c negative 2. After substitute, we have 4 negative 2 to the power 3 minus 2 multiply negative 2 squared plus 5. So we have negative 2 to the power 3 negative 8. Negative 8 multiply 4 negative 32. And we have minus 8 plus 5. So we have minus 35. This is the remainder. Okay, this is the R, the remainder. So we can find the remainder directly by substitute the C in F is C. Okay, just this is if divide by x minus c, by x minus c. But if we have divided by x squared or x squared plus x or 2x minus 5, so here must be divided by only x minus c. Okay, now we can conclude if f is c, f of x polynomial, f is c equals 0, so x minus c we can call this is the factor. Also we can find the remainder directly. This is f of the remainder 0. We have 0. If we have the remainder 0, so this is the factor. If f of c equals 0, so x minus c factor. If x minus c factor, so f will c equals 0. So the remainder 0. When the remainder is equals 0, we have factor x minus c. If we have the factor x minus c, we have the remainder 0 and f is c equals 0 also. Look at this. We have polynomial x to the power 3 minus 7x minus 6, and we need to verify or determine whether x minus 3 this is a factor or not. If f is 3 equals 0, so we no need to find this one. We can conclude directly x minus 3 this is a factor of f of x. Substitute 3, we have 3 to the power 3 minus 7 multiply 3 minus 6. 3 to the power 3, 27 minus 21 minus 6. So this is the 0. So we can find x minus or determine x minus 3 as a factor or not by substitute only. Okay, and don't use the synthetic division. We cannot we can find this or determine the factor by two ways: by synthetic division and the remainder 0, or substitute the 3 in f of x. If we have the f3 0, so this is the factor directly. So since the remainder equals 0, we can conclude x minus 3 equal, this is the factor. Any question? Polynomial and rational inequality. Inequality means we have less than, equal, greater than or equal. Okay, if f of x polynomial, so we have polynomial inequality. If we have f of x rational, so we have rational inequality. For example, x squared minus 3x plus 4 greater than or equal 0. This is called polynomial inequality. If we have 3x to the power 4 minus 2x over x plus 1 less than or equal 0, this is called rational inequality. Okay, because we have numerator and denominator. So this is, we have signed inequality, so we have inequality and we have rational numerator and denominator. This is rational inequality. Now, how can solve the inequality in general inequality? Polynomial inequality or rational inequality? Firstly, must be put it inequality less than, greater than, less than or equal, greater than or equal what? Only 0. Okay. After that, find the f of x equals 0 or f of x is undefined. So we must find f of x equals 0 and f of x undefined. If we have polynomial, only find f of x equals 0. If we have rational, must we find the 2. F of x equals 0. This is from numerators equal 0. And f of x undefined. This is by find the zeros of denominators. Now, after that, we need to determine the intervals of f of x. This is the sign of intervals: positive, negative, positive, negative. Okay, on the real line. If f of x is positive, if we have f of x greater than 0, and we can determine the negative interval if we have in equation in the questions f of x less than 0. After that, we can solve or determine the solution set to solve this application. Look at this example. We have minus 3x minus 2. Wait. Like this. We have this example: minus 3x multiplied by 2 minus x multiplied by x plus 4 all to the power 2 less than 0. So we need to find the intervals that the left-hand side negative less than 0. Okay, now firstly solve this one. So we have minus 3x equals 0, 2 minus x equals 0, and x plus 4 equals 0. Okay, also we can put it as square, no problem. By divide by negative 3, we have x equals 0. This is the first solution. Okay, the second, we have x equal 2. And the third, x plus 4 equals 0. So we have x equal negative 4. On the real line, for the x, minus 3x multiplied by 2 minus x multiplied by x plus 4, and this one minus 3x, 2 minus x, and x plus 4. We need to find the sign of this terms. We have negative 4. This is minus infinity, and this is infinity. We have negative 4, 0, and 2. How many region the real line divided to how many region? Okay, how many region here? We have 3 or 4. We have 1 from minus infinity to 4. The second from minus 4, negative 4 to 0. From 0 to 2. From 2 to infinity. So we have 4 region. Now, you can choose any value from negative infinity to negative 4. We can choose, for example, negative 5. Okay? From negative 4 to 0, we can choose negative 1. From 0 to 2, we have, for example, 1. From 2 to infinity, we have 3. Okay? Now, what's the, after substitute, negative 5 or negative 2, 1 or 1 at x equal negative 5. Okay? What's the value of minus 3x? Minus 3x, this is positive. Okay? Positive. Minus is, sorry, negative 3x and 2 minus x and x plus 4 square. The first one, this is positive. The second, negative 2 minus 5, we have also positive. And last one, minus 5 plus 4, we have negative. So with square, we have positive. So from minus infinity to negative 4, we have positive. After substitute x equal negative 1, we have negative 3 with negative 1, positive, 2 minus 1 positive, okay, and this is positive, so we have positive. After substitute 1, we have negative minus 3 multiply 1, negative 3, 2 minus 1, 1 positive, 1 plus 4 and square, we have positive. So look at this. This is multiplied together. Negative, if we have negative, multiply positive, negative. Multiply positive, negative. So we have negative. After substitute x equal 3, we have negative minus 3 multiply 3. And 2 minus 3 also negative. 3 plus 4, 7 square, 49 positive. Negative multiply negative, positive. This is multiply this one, positive. Positive multiply positive, so we have positive. Look at this example. We need to find the value of x that negative or positive. Negative for this formula or positive. This we need the value of x that become formula negative. So we can conclude the solution is from 0 to 2. This is the solution. Okay? Yes, negative because we need find this formula less than 0. So we need to find the x that become this formula less than 0. So this is negative. Any question? Also, we can apply this method on the fraction. Look at this. If we have fraction or rational inequality, we must find the zeros of numerator and denominators. So x minus 4 equals 0 and x plus 2 equals 0. We can conclude x equals 4 and from here x equal negative 2. So we have 2 0. X equal 4 and x equal negative 2. Put it in the real line to find the sign of this fraction. We have negative 2 and 4. We have infinity and negative infinity. Okay. Now choose the value from here. We can choose, this is negative. Okay, we can choose negative 3, 0, and for example 5. If substitute minus 3, we have in numerators and at x equal negative 3, we have negative 3 minus 4 negative over minus 3 plus 2 negative. Okay, negative over negative, so that we have positive here. At x equal 0, we have negative over positive, so we have negative. Substitute 5 at x equal 5, the fraction 5 minus 4 positive and 5 plus 2 positive, so we have positive here. Okay, so we need to this fraction greater than or equal 0. So we need the value of x that become this fraction positive or negative. We need to find the value that become this fraction x minus 4 over x plus 2 greater than 0. This is, we needed the fraction positive or negative, positive. So we have two regions from minus infinity, from minus infinity to negative 2 or from 4 to infinity. The first one from negative infinity to negative 2 and from 4 to negative infinity, so positive infinity, and put it between them union. So put it from negative infinity, to negative 2 union from 4 to infinity. This is the solution set. Okay. Now, the last subject, this is called the variation. We have three types of variation: directly, inversely, and jointly. Directly, this is the form for various directly. And this is the form for what? For various inversely. And this is the form if we have jointly various. Okay? What's the meaning VD or directly varies? This code, if we have an increase in X, if we given increase in X, we have increase in Y. Okay, all of this case, this is the constant of variation. This called constant of variation. This is the key. Okay, but look at the relation between Y and X. If at increase of X, we have increase in Y, for example, like this. This is VD. When increase of X, increase of Y. كل ما زدنا X بتزيد Y. طبعا within the constant variation K. This is VK. But inversely, we have when increase of X, we have decrease in Y, like this. Look at this. We have X small but Y large. When increase of X, we have decrease in Y. Okay. This is inversely or various inversely. But if we have join, we cannot draw this by 2 dimensions. We need 3 dimensions because we have jointly, we have 2 variables X and W and Y. We have 3 variables. So this is the 3 dimension. Okay. But also, if we have an increase in X, we have an increase in Y. If we have an increase in W, we have an increase in Y. So the relation between Y and X with W, any increase in W or X, we have an increase in Y. Okay? But W and X, we have inversely between them. Now, example about, before example, what's the procedure to solve application has or involving variation. Okay. Firstly, we need to write the general variation. This is inversely, jointly, directly. After that, find the K, the constant of variation. We must find the K, because in 3 types of variation we have the constant variation. After find the or solve the variation and find the constant variation K, we can now substitute the K variation in the model or variation formula. After that, we can use to solve the application. You use the model to solve the application. So we have 2 main steps, step 1 and step 2. This is very most important. Write or determine the variation. This is directly or inversely, jointly. After that, find the key. If we put it the variation formula correct and find the key correct, we can solve it the application directly. Now, look at this example about the direct variation. We have amount of allergy, a medicine that physician prescribes for the child varies directly. So we have varies directly in this model as the weight of child a clinical. So we have the energy, the allergy. This is A, allergy medicine, and we have the weight. This is between them the relation varies directly like this. A equal K V W. Okay. Now this is the formula, but we need to find the K. How can find the K? Clinical research suggests that 13.5 milligram of a drug should be given for 3-pound child. So to find the K, the weight equal K multiplied by weight multiplied by 30, and the dose 13.5. So the K equal 13.5 over 30. This equal what? By calculator we can find 13.5 divided by 30. This equal 0.45. Okay, this is the constant. So we can conclude the formula A equal K. What's the value of K? 0.45 W. This is the formula. Now, what's the first question? How should be prescribed for a child with weight 50? If we need to find the dose directly from A, this equal A equal 0.45 multiplied by W. W equal what? 50. So we have 0.9, I think. Okay, 22, sorry, 22.5. This is the milligram for children with weight 50. Also the B, this is with 60, so multiply B. A equal what? 0.45 multiplied by 60. This equal what? 27 dose milligram. Number C, a nurse want to double check the dosage on the doctor or order of 18 milligram for a child of what weight. This is dosable appropriate. So the C, we need to find the weight for A, dose 18 equals 0.45, and we need to find the weight of the children. So the weight equal what? Equal 18 divided by 0.45. This equal 40 pounds. So 18, this is proper dose for the child with weight 40. Okay, any question? Any question? Look at this. We compute the formula. After that, we can solve it. Okay. Another example, solving an application involving inverse variation. Loudness of the sound measured in decibel dB varies inversely. Okay, so we have various inversely between the measurable decibel and the square of the distance. Between what? Between the listener and the source of the sound. So if we have decibel B or D, put it as D, and the square distance, this is the what's the variable here? Put it A and W. No, okay, so next, K distance D and L, this is the loudness. Okay, so this is put it the loudness L and the square distance D. The relation between L and D with K, this is what? Inversely. Okay, this is inversely. So now we need to find the constant variation K. If the loudness of the sound, decibel 17.92, this equal, but the distance square, I think, distance, square distance. So the D for the distance, but we need to distance or square of the distance. And the distance equal 10. So we have 10 square. So to find the K equal 17.92 multiplied by 100, so we have 1792. This is the value of K. So L equal the 17 or 1792 over D square. Okay, this is the formula. Now, what is the decibel level 20 feet from the speaker? Okay, what is the decibel? We need to find the decibel L, okay, with the distance 20 feet. So this is 20 but square. Don't forget this is the square. So we have 1792 divide by 20 square, we have 400. So this is equal what? This is equal 4.48 decibel, okay, of the loudness. And this is the solution. Look at this. Firstly, find the K. After that, we can put it in the formula. Substitute 20 in the D to find the loudness of this formula in this example. Any question? Another application about joint variation. Joint variation means we have variable k with variable multiply variable. We have like this. Kinetic energy of the object variously jointly. Okay, this is called varies jointly as a weight of the object at the sea level. So we have energy here, energy. This is have relation. We have a relation between this energy and the weight of the object at the sea level, and the square of the velocity, square of the velocity, so V square. So the formula energy equal constant of variation W V square. Now, during hurricanes, 0.5 pound stone travel 60 mile, okay, has 81 joule. So we need to find the constant from this given value. Joule, the for energy we have 81, weight 0.5, velocity 60 square. So the K equal what? 81 over 0.5 multiplied by 60 square. So we have 0.045 like this. This is the constant. Okay. Now, like this. Okay, yeah. Okay. We have energy equal K W V. So the K equal what? 81 over. This is the value of W multiplied velocity square. But this is, we need to divide over energy. So we have 0.045. This is the formula. Now, suppose that the wind speed doubles. Okay, doubles from 60 to 120. Find the kinetic energy. To find the energy equal K 0.045 and the weight, this is the same weight, 0.5 for stone, but the velocity equal what? 120 square. So the energy equal the variation, constant variation 0.045 multiply 0.5 multiply by 120 square. So we have 324. This is the energy. (324 joule). Any question? Any question?